Proving Souza to be Addicted to Speed by Jess Tupin and Disha Patel. We're the investigators of a crash scene in which Mr. Souza, in his new smart car, hit Mr. Chuckran's Jeep Cherokee, and both the vehicles went off the side of a cliff and landed in Daigle's turkey farm. Luckily, Mr. Chuckran was not in the vehicle. He was outside sightseeing, but Mr. Souza will never smell the same again. To start, to give you a little bit of background, we think Mr. Souza was speeding because he was eager to get home to his wife and kids to have some delicious fresh turkey from Daigle's turkey farm. Our goal was
to prove that Souza the loser was speeding before he skidded and hit Mr. Chuckran's car. The speed was 20 miles per hour, and Souza was driving on a dry road, and we took pictures of the mock accident to prove that he was speeding.
This is the model of our accident that we drew. So here's Souza in his 2013 smart car, and there's Mr. Chuckran's car. So Mr. Souza was driving. He started to skid once he saw the car. He hit Mr. Chuckran's car, and they both went off into a pile of turkey poop. We used these measurements to determine
our scale, which was 1 meter, is 23.43 meters. We got this by taking the length of our smart car, which is 2.69494 meters, and dividing that by the length of Chuckran's car, which was 0.115 meters.
And the length of Chuckran's car was the length of the car in the mock accident. To start, we started with projectile motion. Our goal was to find the velocity of the two cars together as they leave the cliff. We wanted to start from the bottom and end at the top. To do this, we used the kinematics, in which we knew y. From our mock accident, we multiplied it by our scale. Acceleration is negative 9.8 meters per second squared, and Vy naught was 0 meters per second. To find Vx, we first needed to find time vertically. So we used the third kinematic, and we found time. Then we worked horizontally, and we used the equation Vx is equal to change in x over t to get the horizontal velocity of 3.823 meters per second. And that's the velocity they left the cliff at.
Next, we did the conservation of momentum. Our goal was to find the velocity at which Souza hit Mr. Chuckran's car. So we did Pi equals Pf. We did mass of Souza's car times the velocity of it plus mass of the Jeep times the velocity of the Jeep equals mass of both of them and the velocity of both of them. We solved for Vs, and we got 10.510 meters per second.
It's also important to notice that the mass of the Jeep times the velocity of the Jeep was initially 0, so we were able to reduce our equation to ms Vs is equal to mjs Vjs. Next, and finally, we use the equation of conservation of energy. Our goal here was to find what we've been looking for all along, the velocity that Mr. Souza was going at before he started to skid, so right where this arrow is, which you can see closer. To do this, we used the conservation of energy. We knew that mu k was 0.7 because he was on a dry road. Our distance, which we measured from the mock accident, we multiplied it by our scale. And then we knew we had to have E therm in our final equation, so right here actually. So we knew we needed to have a force, and we drew a free body diagram for Souza's car, and we have mg down, Fn up, and Fk working in the opposite direction in which he was skidding. Fk is equal to mu k Fn, and which is equal to mu k mg because Fn is equal to mg. So we did EI is equal to EF, EK initial is equal to EK final plus E therm because he doesn't stop when he hits the car, he's still moving. We solved that for the initial velocity, and we used that answer, 12.97 meters per second, and we converted it to miles per hour to get 29 miles per hour.
This proves that Mr. Souza was going 9 miles over the speed limit before he skid and hit Mr. Chuckran's car.
This proves that Souza must be addicted to speed.